Hi everyone. Let's start our journey in the GitLab side by understanding what is GitLab. So in this session, we are going to see the general overview or the definition of GitLab in the layman terms. So layman terms as in into the very simple use case in order to understand the simplicity of the GitLab. So it's a web-based DevOps lifecycle tool. So when we talk about the DevOps lifecycle tool, as in it covers all the aspects from the end to end into the DevOps side that provides a Git repository, which is the starting phase of storing the code with the features like CI/CD, building the code, managing the code, and even the additional functionality like issue tracking and project management. So in short, it is a complete DevOps tool. That's the main functionality of the GitLab. So from the starting of the managing of code till the deployment, additionally, where we have to manage issues like we do in Jira, create the weekly page like into the Confluence, everything project management related can be done into the GitLab. So it's a complete DevOps tool, and other than that, we don't require any further tool for the utilization. So it is a self-sufficient tool into the use case of DevOps side. Its key features are version control, so supports Git for the version control, enabling teams to collaborate on the code efficiently. So if we are managing the code for the entire team at a singular pace or the centralized system, so it provides that functionality. The Git functionality is added into the GitLab. Moreover, CI/CD integration, the task that we do to deploy the things and build the things and even automate the process, all the things are available at a single place. Automates the build, test, and deployment processes. Project management. So even the issue tracking, creating the sprints, managing the milestones, everything related to the issue tracking, time tracking, and project planning is covered into the GitLab side. Moreover, it's a place where everyone can collaborate to review the code, merge requests, and enhance the documentation. So all those functionalities are available into the GitLab tool. So in the GitLab, it's a complete CI/CD tool that is available into the market for the use case. That's the main functionality or understanding of the GitLab. So that's all from this video, and start our journey into the GitLab side. Thanks a lot. Hi everyone. In this session, we are going to understand CI/CD. So when we go about the DevOps side, everyone is talking about CI/CD. So CI/CD is one of the key concepts that you are going to hear from the starting till the end. So CI stands for continuous integration, and CD can refer to continuous delivery or continuous deployment. So this is the working that we are going to see, and this is how the DevOps is completely based on. So in the continuous integration, we make the improvements or the changes or the enhancements that covers out comes under the CI side. Whereas continuous delivery means the when we are delivering the things to the customer with the manual interventions. So final approval is taken from your manager or the business head in order to deliver it to the production level environment. Into the deployment, it is automatic delivery to the end-to-end customer. So this is how the basic difference works out into the utilization. So we are going to understand more about this into the depth way into the utilization. So what is CI/CD? CI/CD refers to the three terminologies. CI stands for the continuous integration. CD can refer to the continuous delivery and the continuous deployment. In the continuous integration process to get code and package it, then send to the CD for the further processing. So as there is new update into the code, or we are developing the code for the first time, we have to make it into the package form so that it can be provided to the customer for using it. So this is how the continuous integration works. So in the continuous integration, we make changes or build. After that, it is transferred to the continuous delivery or the continuous deployment to deliver it to the end-to-end customer. If it is working with the continuous delivery, the package is deployed on the system after the manual trigger. Here the keyword is manual. When the intervention is the human, then the manual trigger takes place and it's a continuous delivery. When the process of deployment of package takes place automatically, so when the things goes automatically, it's called continuous deployment. So it's totally based on the organization to organization whether they want to opt for the continuous delivery or the continuous deployment. Because some in organization they prefer the manual approval to be taken at the end before the final delivery. Then in some of the organization, if they test it and build it, then they want it should be automatically deployed for the use case. So understanding it more about it, so let's say this is my code and it has been packaged. So taking an example of a Java based application, and the package is into the war side and it has been provided into the cloud or stored somewhere for the utilization. For the deployment, it is going to be delivered automatically after the testing purpose and the build purposes. Whereas if it is a continuous delivery, a manual intervention is going to take place to deliver it to the end customer. This is the basic difference between a continuous integration with the usage of continuous delivery for the deployment. So in the industry, the continuous deployment and the delivery is basically based on the organization needs, how they want to perform it. So that's the basic understanding of CI and CD for the use case, and you are going to utilize this terminologies from the starting of the DevOps till the end. So that's all from this video. Thanks a lot. Hi everyone. In this session, we are going to see the utilization of the runners into the working. Till now, all the jobs have been running in our shared runners. But when we work into the project, we want a specific runner or the self-hosted runner for the utilization. Why so? First of all, we don't need to wait. So waiting time is reduced. So this is reduced. That's the main functionality of it. The second is the security concern. So if you want to achieve all those things and achieve the process of smooth working into the GitLab side, we have a specified runners or the self-hosted runner for the working. So generally the shared runners are utilized when we are working on the journal working or doing the POCs. Let's understand more about the runners, how we are gonna utilize it. So runners are lightweight build environments used to run the jobs in the GitLab pipelines. So they are responsible for executing the jobs into the pipeline. So let's take an example. So I have created a pipeline file. I need to make sure it runs perfectly fine. So how it needs to be performed, where it needs to be performed, that is done through the runner. So where is selected by the runners. How they work? They pick up the jobs from the pipeline and runs them into the specified environment and then sends back result to the GitLab. So all the tasks that we are working that are going to be taken by the runners and they are going to run it and execute it and then finally send back the results to the GitLab. So let's understand the different types of runner. Shared runners. The GitLab default is called shared runners. So all the jobs that we have been running till now are working on the shared runners. So they are directly managed by the GitLab and shared across all the projects that you have been working on. Then we have self-managed runners. So when we want to host the runners on our own, like my server, my Dockers. So all those things are going to be managed by the users. That's the main thing. It needs to be managed by the users. Ideas for jobs that require specific resources or configuration for the working. And similarly, group runners are the one who is shared among the entire group. So it can be shared among the different projects within the specific group, the utilization. In the industry, we mainly focus on the self-hosted or the self-managed runners for the working. Now, the major benefits of it is the scalability. So if we are working into the environment of the project that is highly complex and requires mainly n number of runners to be available, then we can scale them horizontally, handle the multiple jobs in parallel across the multiple environments. It offers the flexibility. We can choose different types of runners like your instances, which is called your local machines. Then we have Docker, we have Kubernetes for the utilization. So based on your requirement, you can create them as per your utilization. And furthermore, you can customize based on the dependencies that you have to use, the tools that you have to use. Taking an example of Java, you do have JDK requirement, then you have Maven requirement to build it. Similarly, for the Node.js, you have the requirement of Node and NPM for the working. So for all the different types of environment, we do have the dependencies and particular tools. For that, we have to make the customization that can be achieved through the runners. Now let's understand the different types. So these are the three types: shared runners that are provided by GitLab, group runners shared among the group, and the self-managed is the runners hosted by or managed by the users. So users are the one who manages them. So they are the manager. Whereas in this, the GitLab is the controller or the manager of the shared runners. So in the industry, when we work into the project, we specifically focus on the self-managed, but in the general working or the jobs which are not requiring any specific customization, we can even opt for the shared runners. That's how the general working goes into the industry. So that's all from this video. Thanks.